I dislike being the bearer of bad news, but the technological changes warned about since last year are coming to fruition. These changes are often driven by powerful entities, which in today's world include the three-letter agencies and the surveillance complex. They have achieved their goals, and you have all been deceived. By the end of 24, technological advancements will allow the scanning of all content on your devices before encryption, effectively ending security and privacy in end-to-end encryption on standard devices. The illusion of privacy in end-to-end encryption will soon be shattered. A new method of encrypted communication will be required, but it's not that they've broken encryption algorithms. The surveillance complex desires this capability, and tech giants have complied. Skeptics will call this fearmongering, but history will eventually prove them wrong. Supporting our content by liking this video, subscribing to our channel, and activating notifications is welcomed. Sharing is caring. My theory is simple. If a technology has the potential for misuse, it will be misused regardless of its purported good intentions. By the end of 2024, all new devices will have local AI and NPU chips, marking the end of end-to-end encryption for apps like Signal, Telegram, and WhatsApp. However, I have an idea on how to circumvent this, which I'll discuss later. To understand the new change in computing called the U-chip, and how it will end end-to-end encryption, stay tuned. The term NPU stands for Neural Processing Unit, an AI chip that will be part of all new devices by the end of 24. Currently, the NPU is already in all new iOS devices as the Apple Neural Engine, initially called the A4 Bionic, with newer versions following. There's a Mac version known as Apple Silicon M, which are ARM versions of the Mac. Google has the Tensor chip, which debuted in the Google Pixel 6. Microsoft announced the Copilot Plus PCs, NPU-equipped Windows machines running Snapdragon X Elite chips from Qualcomm, the first ARM chips to run standard Windows. Intel and AMD are beta testing their NPU models, expected by the end of the year, with Intel's chip known as Lunar Lake. If you're buying a new computer running iOS, macOS, Windows, or Android, it will have these AI chips, or NPUs, and these operating systems will use them. This means that in 5 years, most computing devices in the world will be NPU-powered. Today's focus is on the NPU chip and its effect on end-to-end encryption and privacy. In 2015, 2 terrorists killed 14 people in San Bernardino, California. They were later killed by the police, and the motives for the attack remained a mystery. The only potential clue was in their iPhones. The FBI asked Apple to break into the phones, but Apple refused. Apple faced heavy pressure, including from tech billionaire Bill Gates, to break the encryption. Apple likely realized that breaking into iPhones would severely impact their marketing, so they resisted. After this incident, heads of the 3-letter agencies publicly discussed the encryption problem, hindering their surveillance efforts, claiming it was for public safety. They demanded a solution. Uninformed politicians made ineffective laws in Australia. For example, while agency heads proposed scanning content pre-encryption. For instance, if someone could see your screen as you type on Signal, Signals encryption wouldn't matter. End-to-end encryption is bypassed if someone can see the screen. This is akin to someone watching over your shoulder as you use any messaging app. There are many ways to achieve device surveillance. Key logging records, every keystroke, mouse click, or finger tap. Screenshots capture your screen activity. Another method intercepts text rendering on a GPU before it's turned into a graphical font. The limitation of screenshots is that they take up a lot of space, and graphical data is not easily categorized by traditional computing devices. Enter the NPU. The NPU solves the problem of analyzing graphical images with an image processing AI model. The AI features of the NPU enable the OS to understand what's in an image. AI can identify objects, people, and actions in a picture in detail. These are common tricks now possible with photo editing AI on phones. AI can also do character recognition and facial recognition in graphical images. Apple first leveraged this new technology for surveillance a couple of years ago. They announced they would scan iOS devices, meaning perform on-device scanning, supposedly looking for illegal photo content like Csam. Why this became a sudden priority was never entirely clear. They provided various explanations of how this would be safe, because the neural engine on iOS would perform the analysis, not a human. The new solution was to use AI to surveil phones, essentially having someone watch over your shoulder, but with a marketing spin that no human is directly involved. This was perfect for big tech, meeting surveillance complex requirements while claiming no direct human spying. Last year, the EU, UK, and US attempted to pass laws making device scanning mandatory, supposedly to protect children from illegal photos like Csam. The UK successfully passed such laws, but the synchronized support for local device scanning by Western countries seemed pre-planned and coordinated. Now, in 2024, the infrastructure gaps have been filled. All devices will have the technology to let AI scan them for content. Skeptics will accuse me of fearmongering, but the hardware to have someone virtually watching over your shoulder is in every new device. Apple has already demonstrated this. The question is whether software will enable it. Let's look at the evidence. Apple proved the concept was feasible when they announced their ability to scan for Csam, then suspended the project. Or so they claimed. There is no doubt Apple devices are scanning all photo content and creating a database of what's on your phone. On an Apple Silicon Mac, this process is managed by Media Analysis D, which runs continuously and can't be stopped. There's no current proof this photo data is sent elsewhere, but the analysis of images is stored on the phone as neural hashes. Apple could easily include instructions to scan for any content, including facial recognition, and do so surreptitiously on any group of Apple devices. The capability is there. Then, last month, Windows announced NPUs. In Windows 11, key logging and screenshotting of your activities were enabled as standard events, and the NPU will analyze the screenshots for content and store that data historically. The mechanisms for pre-encryption scanning are now in place. The only thing missing is the command and control structure to query your device from an external party. Windows setup is more extensive than Apple's. Windows records everything you do on a Windows computer. On a Copilot Plus PC, Windows takes screenshots every 5 seconds. The NPU analyzes your activities and stores that data in a database of your activity history on your computer, referred to as Windows Recall. Microsoft is reportedly pulling back on Windows Recall, but this is a beta product, so expect continued development. Someone found unencrypted data from Recall, so they might be working on hiding this with encryption. Microsoft is capturing everything and not denying it. Apple scans photos, but their data is not comprehensive enough to fully surveil your activities. Microsoft's case is more complete. Remember, Bill Gates supported breaking encryption to complete this surveillance structure. The Copilot AI, essentially a private version of OpenAI's ChatGPT or a large language model, is preloaded on all Windows 11 machines. This Copilot AI can scan your Windows Recall to see your activity timeline and use this data as part of its intelligence. Except Copilot operates in the cloud, an external server capable of analyzing your personal history on your machine. It's unclear if the NPU can perform some large language model, LLM, functions like ChatGPT directly on your device, or if it must send data to the cloud. Apple's newly announced Apple Intelligence claims to provide some LLM functionality through the neural engine on its newer chips, but details are vague. Can the connected AI scan your content and report it? Can it read your device content and analyze it? The answer is likely yes. AI on Microsoft, Apple, and Google servers knows what interactions it has with any device, making this task trivial. If agencies claim national security needs and request access to certain device content, it could be done. Your device, especially on Windows, already has key logging and screenshot capabilities to monitor what you type on apps like Signal, Telegram, and WhatsApp. Using end-to-end encrypted apps no longer guarantees absolute security and privacy. Some might think using Linux could be a solution, since it wouldn't have NPU features or local device content scanning. While true, security requires both parties to use safe hardware and an OS. Thus, safety only exists in Linux-to-Linux communications. However, it's likely your contacts use mobile phones with device scanning features, complicating secure communication. End-to-end encryption remains possible because the encryption algorithms themselves haven't been broken. However, achieving true security and privacy will be more complex and require new hardware solutions. Apps will need to detect if the message recipient is using certified hardware. One way to prevent surveillance is to use a device not connected to the internet, similar to cryptocurrency offline wallets like Trezor. This device would need a screen and keyboard, or be phone-like, running an app to retrieve messages by connecting to another device. Offline, you could decrypt the message and pre-encrypt a response, sending it via your main device once connected. End-to-end encryption keys would only reside on the offline device, which would need security chips to enforce verification. The goal is to ensure no unencrypted text is visible on compromised devices like Windows, iOS, macOS, or Android. All encryption and user interface functions would occur on the external device, making the process tedious and less convenient. Many people would resist this inconvenience and continue using current schemes like Signal, Telegram, and WhatsApp, accepting that surveillance is inevitable. This situation mirrors today's use of SMS, a common communication method where carriers and agencies retain copies of all texts. We are now trapped, and solutions are not simple. The infrastructure for surveillance is mostly in place and nearly complete, with AI likely watching our device activities soon and potentially monitoring us physically in the future. As AI technology continues to advance, the capabilities of NPUs and other AI chips will only increase. This means that surveillance will become more pervasive and sophisticated. The idea of having a virtual someone watching over your shoulder will not just be a metaphor, but a reality embedded in every new device. The surveillance complex will have the tools to monitor almost every aspect of our digital lives. Governments and corporations will play significant roles in this surveillance ecosystem. While governments may justify surveillance in the name of national security or public safety, corporations may comply to avoid legal repercussions or to gain favor with regulatory bodies. The intertwined interests of state and corporate powers will ensure that these surveillance capabilities are developed and deployed. The ethical implications of such pervasive surveillance are profound. The erosion of privacy and the potential for misuse of surveillance data can lead to significant abuses of power. The balance between security and privacy will be continually challenged, and the voices advocating for privacy may find themselves increasingly marginalized. Public awareness and advocacy will be crucial in addressing the challenges posed by these technological changes. People need to understand the implications of NPUs and other surveillance technologies on their privacy. Advocacy groups and privacy activists will need to push for regulations that protect individual privacy rights and prevent abuses. Open source and decentralized technologies could offer some respite from the pervasive surveillance capabilities of NPUs. Open source projects allow for greater transparency and scrutiny, potentially leading to more secure and privacy-respecting solutions. Decentralized technologies, such as blockchain, could provide alternatives to centralized surveillance infrastructures. Digital literacy will become increasingly important as these surveillance technologies become more prevalent. People need to understand how their devices work, the potential privacy risks, and how to take steps to protect themselves. Education and awareness campaigns can play a vital role in equipping people with the knowledge they need to navigate this new digital landscape. While the surveillance complex is powerful, there is always potential for resistance. Technological advancements can be countered with other technological solutions. Privacy-focused startups, innovative encryption methods, and new communication protocols could emerge to challenge the status quo. The fight for privacy is far from over. That concludes today's discussion. Please remember to like, comment, and share this content with fellow enthusiasts and relevant forums. Thank you, and we eagerly anticipate your presence in our next episode.